Welcome to today's webinar on deploying i2 in a cloud environment. My name is Trisha Shelley, and I'm the Aggregation Marketing Manager for Fora Inc. Before we get started, I would like to just share a few administrative details. If you have questions during the presentation, please use the chat feature, and our presenters will answer them as soon as possible. In case your question is not addressed during the webinar, we will provide a response to you after the event. We are recording the presentation, and the recording will be shared with all attendees after the webinar's conclusion. Now I would like to introduce one of today's presenters, Mr. Mike Mumaw, who is a technical architect with i2. Mike, the floor is yours.
Good day, thank you. Welcome to the webinar, Deploying i2 in the Cloud. My name is Mike Mumaw, and I'm the i2 architect for North America, coming to you from Durham in North Carolina. So today we're going to, here's the agenda for today's webinar. First of all, I'm going to talk about do a quick introduction of i2, pretty quick. If you've made it to here, you're probably aware, but quick one-slide introduction to i2. And then we're going to talk a little bit about Analyst Notebook virtualization in the cloud. That is the front-end workstation. After we do that, Mark Todd, who is the i2 Group Chief Architect, that is the Chief Architect for the entire strategy for the product and the group, the team, we'll talk about i2 cloud technology strategy. I think he'll be the hallmark of he'll be the real key part of this webinar as he talks about what our strategy is. And then equally important, Joe Krozak, founder of Krozak Information Technologies and a strong partner and long-term partner of the brand and the products in the company, will be talking about deploying i2 in a cloud environment. Krozak has deployed a number of enterprise deployments of i2 into the cloud at production clients, and Joe has a lot of good information about how it can be done and some of the best practices in order to do that. So we'll jump right in. The first thing I want to talk about, just as by way of introduction, in case you maybe just know Analyst Notebook as the workstation app and are interested about more, i2 has been around for over 30 years. Started in law enforcement, but now we have quite a few missions. Started with the precursor to Analyst Notebook, but now we have several products from Analyst Notebook through Enterprise Solutions. And so here you can see some of the sectors we have, as well as, of course, worldwide presence as well. So, a couple of things that I'll point out is traditional use cases such as law enforcement and counter-narcotics, and I would even call counterterrorism and counter-fraud traditional i2 use cases, right, where our clients would do that kind of thing. But also modern use cases such as cyber warfare and crimes associated with cryptocurrencies and Bitcoin and that kind of thing as well. So, quite a few use cases for i2 across use cases and across the world. Happy to answer any questions about this. Again, I think probably if you made it here, you're aware of this. If you aren't and you'd like to have more information about i2, I'd like to point you to i2group.com, our website, where there's quite a bit of resources as well. You can find information on our regular training that we do. We do free online training as well, which could be helpful to many people. Next slide. I want to start with the very simplest of architectures to talk about, how the i2 products go together, just simply so that when Mark talks about our strategy, it makes sense in case you're not familiar with the underlying components. On the left, you'll see Analyst Notebook, which probably everybody's familiar with here, where you can do your network analysis, your geospatial analysis, temporal analysis, all the things you're used to installed in your local workstation. But also, especially with our products, Analysis Hub and Analysis Studio, we have a component called i2 Analyze, which runs on the server on the back end. So traditionally, you'll have a number of Analyst Notebook users scattered around your organization on different workstations, and you'll have typically one deployment of i2 Analyze in a data center somewhere supporting those to do things such as provide a shared intelligence picture, to store and collaborate on shared charts, Analyst Notebook charts, or to connect dynamically with external data sources through i2 Connect. So traditionally, all this stuff has been installed directly on the workstation, directly on servers in the office and in the data center. But what we're going to talk about is options beyond that. And i2 Analyze is the one thing I'd like to focus on, because not everybody's heard of i2 Analyze, which is the underlying server component for our products. So Analyst Notebook in the cloud. Analyst Notebook our most powerful tool is a workstation-based tool. It does only install on Windows-based product operating systems. Everybody's probably pretty familiar with that, but it does have massive amounts of capability and it's super useful. If one of your challenges is to not have software deployed on your individual workstations for one reason or another, there is now a really good option to virtualize that, to what I call here on the top right, make Analyst Notebook available streaming on the network. Some of our clients for a while now have installed Analyst Notebook onto virtual desktops, which can be connected to via workstations. But going forward, one good option, if Amazon AWS is an option for you, either a private version of it like the US government has or the commercial version, which everybody has, is to install Analyst Notebook onto Amazon AWS AppStream 2. That would allow all of your users to access Analyst Notebook via just a web browser with the full capability of Analyst Notebook and quite good performance. By way of a sort of an anecdotal example of performance, I regularly demonstrate this capability in the US to the US federal government running on the AWS instance in Europe, and the performance is fantastic. Often it's faster than the instance that's installed on my local workstation because workstation is slightly slower. So those are two options to get to Analyst Notebook, but the other two capabilities we have right out of the box, products specifically, are Notebook Web and Investigate. You can see at the bottom of the slide. i2 Notebook Web is our web-based analysis tool. It comes with Analysis Hub, and it allows you to do full analysis just in a browser in a cloud native way. Does have slightly less capabilities from Analyst Notebook, but on the other hand, I would characterize those capabilities as very rapidly increasing on a quarter-by-quarter basis as we deliver additional capabilities. And also, of course, since the capabilities are delivered in a web browser, as those capabilities roll out, you don't have to change the end user workstations to adopt those capabilities. Just the backend server needs to be updated. And finally, i2 Investigate, which I like to think of it as a curated view of the intelligence, not necessarily applicable for all analysts, but great for non-analysts and good for analysts that need a quick analysis of their data. Basically, you can, and again, this fully runs in the browser, comes with our products out of the box, and you can immediately use it if you have the appropriate products. You can search for a target, a person, let's just say, and immediately, without any kind of querying and manipulation, you can see a full curated view of that person. You may see their associates, you may see their geospatial activities, you may see their link, their relationships in the link chart, all immediately and without having any expertise in the tooling. So a lot of our clients like this, or maybe use this in combination with Analyst Notebook. So these are some ways that you can get full access to the front end of i2 in a cloud-oriented way, in a virtualized way. At this point, I'm going to turn the webinar over to Mark Todd, who's going to deep dive further into the real cloud strategy. So Mark, I'll pass it over to you.
Hi, everyone. So my name is Mark Todd. I'm the Chief Architect of i2, and I'm responsible for all of our product technology. So I'd like to spend this time talking a bit about our cloud strategy, in particular about making it easier to deploy i2 products in a cloud environment. So we've spent a lot of time looking at cloud and trying to understand how it applies to both us and to our customers. And the conclusion that we've really drawn is that for many organizations, cloud is an opportunity to modernize. So rather than just doing a lift and shift and taking the applications you have today, running in the data center, and then moving them to the same application on the same computer running in cloud, again, a lot of people are seeing it as an opportunity to modernize the way they do that and to reduce costs, improve a whole bunch of things. So to try and describe what that might mean, I'm using something called the AWS Well-Architected Framework, which is something that AWS provide to try and give you an idea of what a good architecture looks like, to kind of describe the kind of things we're trying to solve. So the first one is operational excellence, and that's what they call a pillar. And what operational excellence means is the ability to take your application and then frequently, reliably, and reversibly get it to your users. So what that enables is user value to quickly move from a piece of software into the hands of an actual user. And the important part there is, because it's reversible, if there is an accident or it goes wrong, we can immediately revert that without having any impact really on the user community. And that's really the foundation of what the DevOps movement is about. It's really taking this world of monolithic deployments only happen maybe once a year to a more continuous delivery of value to the users. So that's the first pillar. The second pillar is around security. Now, we're all very, very conscious about how important security is today, and the number of problems people are having out there getting hacked. So what we think is that there's a real opportunity with a cloud vendor to leverage technology that simply was only available to the enterprise a few years ago. And they've essentially democratized these advanced security tools and made them available to everyone. So now it's possible for a mere mortal to actually build a very secure application environment inside one of the cloud vendors. So the third pillar is around reliability. And put simply, that is the ability to quickly recover from failure. And also, if you do have spikes in usage, to be able to adapt your infrastructure to cope. So to the end user, the system is nearly always available. So the fourth pillar is around performance efficiency. And that really is, it's paying for what you use. So if you have a lot of users, you need a lot of compute. And it's fine to pay for that. But when you have 2 users in the middle of the night, then you shouldn't be paying for that hardware. So this is the whole idea about being able to efficiently use infrastructure as needed. And last but not least is cost optimization. So that's really about driving down the cost of a deployment to the minimum that's actually needed to deliver value to the users. So we then asked our questions. How can I2 help in this modernization process? What can we do to make ourselves more relevant and help people with those transformations? And we really come up with 2 approaches. The first is a cloud-ready installation option. So this is just simply putting our software into a place where we can leverage the modern technologies that you find in a typical cloud vendor. So that's kind of one piece. And the other thing is software as a service. So rather than asking our customers to actually go through all this and deploy the software, we're asking ourselves, well, can we do it for you? So we're looking at SaaS as a way to quickly provide that value to you as a customer. So they're the kind of 2 things we've looked at. So the first one is cloud-ready installation. So what do I mean by that? So I've kind of taken something that I've heard 1,000 times over the years as an engineer, which is the phrase "works on my machine." And typically, anyone who's ever worked in an engineering team would have heard this. It's when you're sitting there on your computer, your software is working perfectly, it's all brilliant, but your colleagues, your other engineers, are saying it's not working. And then you hear this phrase. Now, there's a multitude of reasons why that's the case, and that can happen. But when it happens to an actual user, as opposed to just another engineer, obviously that is fatal, because now we have a piece of software that simply does not work in the environment it was running in. And that's been a big problem historically in all IT. So what we're trying to do is shift that paradigm of works on my machine into works on our machine. So we really want to be able to actually share that machine in quite literal sense with our customers and indeed ourselves. So that software running on my machine as an engineer is indeed identical to the software you're using, and therefore it will actually work. So that's kind of the idea. So how do we achieve that? The whole concept of sharing a machine is not new. Virtual machines are everywhere, and they're indeed the mainstay of many cloud vendors. So yeah, they're here to stay. But virtual machines have some problems. So whilst it's brilliant that you can take a snapshot of a running computer and put it somewhere else, which is what a virtual machine does, it still goes out of date. So it needs security patches, the software needs updating, so you have to look after it. And at which point you're kind of back where we started. So you now got not quite sure if that machine is the same as this machine. So the kind of counterpoint to that is how we deal with that. Well, they use IT automation. So things like Chef and Ansible. And we automate the process of either making the virtual machines or automate the process of maintaining them. And that works. And it's used by lots of people. But it isn't very efficient. So what's happened is this new way of doing things has emerged. And this is obviously kind of really driven by the company Docker. It's not actually their technology per se, but they very much turned that into something we've heard of. And that's also driven things like Kubernetes and OpenShift and all the things you've probably heard of from, if you've ever been to a technology strategy conversation. This whole idea of containers. So we've looked at that problem, and we think that the thing we can do to best help is start to deploy using containers. So what is a container, and why is that any different to VM? So I'm going to try and explain it. This may not go that well. We shall see. So in a virtual machine environment, you have a physical machine, the infrastructure, in most people's word, the actual laptop. And then they have a thing called a hypervisor. And what that does is it virtualizes the infrastructure. And all that really means is that on your one computer, you can now install several copies of an operating system. And the kind of idea, if you want to have something that's kind of completely a replica of what you started with, is you have your operating system, you have your applications installed, and then you take a snapshot of it. So if you want to run 2 or 3 applications on a single machine, you end up needing 2 or 3 virtual machines. And that works, but it's very resource intensive, and it's kind of a heavy way of doing that. So the alternative, which has been popularized by Docker, is instead of virtualizing the infrastructure, you actually virtualize the operating system. So we have one computer, one operating system, but then what we have, there's a very clever piece of Linux, which allows you to get a kind of isolated, virtualized space in that operating system. And that's where we put our application and also all the OS dependencies. So we can actually have different variants of Linux on all different applications, but they're all sharing the same underlying kernel in the operating system. Now, the important point about this is you can run a whole lot of applications, and it's very, very efficient. There's actually very little overhead in running this versus running this natively actually on the host operating system. To the point, you can even run something like an echo hello inside a container. Just run the container, echo hello, close down, and it will feel like you type that in the command line. It is very, very quick, and it's very, very efficient. It is almost identical to just running a normal process on the underlying machine. So it's a great piece of technology, and obviously it's very popular because of this ability to reproduce our environment. So how are we going to get this to you? Now, I kind of call this the double sheep dip, which I fear may be a British phrase. I don't know, but never mind. The idea here is we have our code, we push it to Git, and then we've invested in some security technology which scans it and makes sure we haven't introduced any nasty CVEs into our software. We then go and package all that up, and we turn this into a thing called an image. An image is this kind of combination of your OS dependencies and your actual application. And that's the thing that you can then run a container from. So what we then do with that is we send it to Docker Hub, where we scan it again, this time looking for OS CVEs. So we are quite paranoid about security. And we put that in something called the Docker registry. Now, at that point, it's available to everyone. So we can see it, and we use that internally. But the point will be all our customers can see it too. And then the theory is then take that image, bring it onto your host operating system, and then you get the piece of software that I sat down and wrote as a developer, and you can run them all in containers. So that's the whole paradigm, and which means if we get a security issue, or we want to give you a new wonderful version of our software, we can do that very quickly and get it to you in a very reproducible, safe fashion where you've already got a lot of confidence that it's going to work without having to jump through all the hoops you might have done previously. That's the idea. Now, having kind of come up with this idea of how to solve the installation problem, which is the container, what we've done then is look at, well, how can we use that ourselves in SaaS? And I've tried to kind of describe that in terms of the pillars we discussed in the first slide. So this one is about the operational excellence. and it's saying, right, we need to be able to get small changes to customers quickly, and they need to work. So we've taken that to kind of the extreme, and we use a thing called CloudFormation. And what that actually allows is us to deploy the entire environment, including all of the infrastructure, by defining some code and then running it. So we don't actually go on, and there is no system admin on AWS for us. That's completely automated. And that also means that, importantly, if we do get something like a suspected security breach, we can actually just remove the system and recreate it again. And it's very hard to be inside a system if it doesn't exist. So there's some really good characteristics about how that works. And it's also very reproducible. So we always know what we've got, and we can always make it up to date. That's kind of the whole premise there on that. And just the only other thing on this slide is really we're using something called Secrets Manager, and that allows us to then really carefully control the secrets that you're using, such as passwords and private keys. So this one kind of looks a little bit about reliability and efficiency. And the wonderful thing about AWS, which would be impossible to reproduce, at least for me, I don't really have the resource to buy a data center, is you can actually have these multiple availability zones. And what that means is somewhere in the UK, for example, there are 3 separate data centers in AWS. In some US regions, there's 7. And that they're all completely separated, have their own power supplies, their own internet access, own everything. So even the eventuality there's a major power cut in, I don't know, a state or a county in the UK, the system will carry on working. And then we make use of that to give you the high availability that we want. And also, in terms of those spikes in scale, we can deploy containers as we need them and increase that number when there's more users and decrease it when there's less. That's the general idea. That's kind of that one. Then onto security. So this is a network security diagram. And what we do is we use something called Cloudflare, which you may have heard of, which provides a web application firewall, and that protects us from DDoS attacks. It also scans all our traffic and looks for people trying to actively attack our system. So that kind of fronts the system and also provides full SSL and makes sure that we've kind of got a nice front door on the system. And inside our DRS, we then have we make full use of the VPC, which is their virtualized networking. It's allowed to do things that simply aren't possible in on-prem deployments. You get very sophisticated control of exactly what machines can talk to what machines, and we can tie everything down. And so it's very isolated. And the other thing we do is we use a thing called guard duty, which actively looks at the system and goes, that's a bit odd. Why has Mark started accessing the system at 3 in the morning? Well, that has happened before. And it's to kind of look for anomalous behavior and then let us know that we might have a problem. So that's kind of the first one. I'll then have a second security slide. I apologize. This diagram is difficult to understand, but it's just giving an impression of kind of the way we're approaching these things. So one of the kind of real principles of good security design is about least privilege access. And we've taken that to quite an extreme. So one of the things we're really worried about is not our system admins. We trust them. What we don't trust is that someone might have got their password, which can happen for lots of reasons. So what happens in that event? So when a user comes along and logs into the system because they have to do something to it to keep it alive, we obviously use Azure to do that auth. We've got 2-factor auth on there, so we check who you are, and then you get a token that lasts for maybe 15 minutes. Now, the only thing that gives you access to is it allows you to access what is called a runbook, and that is a procedure for doing something. It doesn't allow you to access the system. You can't get onto machines, you can't talk to Secrets Manager, you can't physically go and talk to any AWS. All you can do is run this runbook. Now, that runbook then gets some elevated privilege itself, which then does certain operations on AWS, some of which in turn have yet another kind of set of privileges associated with them. So at each point in the kind of process, you only get access to the things you absolutely need to do that job. And that makes it very hard for a attacker to penetrate the system. Not impossible, because no such thing as impossible. And there are always going to be vulnerabilities in systems, but it gives you this kind of it makes it very difficult to get access to the data for very long. That's kind of the idea, and we spent a lot of time trying to investing in that, which is again very well supported in these cloud environments. Okay. Now, the important thing about these things is, whilst I can put up some slides and claim that I've done all the work and it's all going to be amazing, we should probably check our homework. So what we have done is we've already got ISO 27001, and we have the Cyber Essentials certification in the UK. What we're doing right now, I mean, literally, is we're in the midst of a SOC 2 audit, and we are we're getting independent compliance that we have built the system in a way where it is meeting these kind of practices that I've talked about. And yeah, we do rely very heavily on AWS to do the heavy lifting, but it's obviously on us to apply them correctly to make sure this is a very safe environment and can be trusted with our customers' data. Okay. So last but not least, just kind of a bit of a status update on where we are in this journey. So we've been working on containers for quite a while, and we already have an open source project which you can access, which does two things. The first one is we took our containers and gone, well, what can we do with them? The first thing we did was we made it easy to spin up an I2 Analyzer environment in a kind of really full form as well. So it runs Prometheus, Solar, Grafana, Zookeeper, Liberty, a load balancer. It has a whole bunch of stuff in it, which makes the system really super representative. So it's like what you'll deploy for real. And then we allow you to then quickly iterate over your configurations in it. So that's the first thing, and that's available today. And then the other part is we built a reference architecture. Now, this wasn't targeted at any particular environment. It just shows how containers could be used to do this. So we examine SSL, secrets management, and yeah, how you go about deploying and maintaining and changing the database and all the other things you need to do to maintain the system, including HA. But it doesn't target any particular cloud vendor or technology. It just shows how it could be done. That's what we've done so far. What we're doing next is, when I showed that diagram about deploying to Docker Hub, we're getting to grips with how we support that properly. So, how long those images are valid for, how we support upgrades and all those things. And we're working that out. But the idea is then to provide those images in a supported fashion so you can all use them. And that will be coming soon. The other thing we've kind of looked at, which we think is kind of useful for a whole section of customers, is when the deployment is small, you may not want to get involved with a full Kubernetes deployment. And it's a lot of work. So what we're trying to do is kind of get to the point where you can just take a single box with Linux on it, run a couple of commands, and then you'll actually get a running environment. And the idea is we'll also, out the box, integrate that with SAML, OIDC to give you auth. We'll integrate that with your backup system, so S3 or shared file system, so you can very quickly get the backups running. And also, we're going to put a small admin UI on it. And the idea is that the infrastructure installation is a couple of hours work for an admin, but going forward, you can perhaps leave that to one of your users to actually do the maintenance operations, which would largely be restarting the system or making some minor configuration changes. That's the idea. And so we want to get to this kind of single box deployment, which is really quick. And then at the other end of the spectrum, this is all about I2 Online, and that's our true SaaS offering. Currently, that's in beta. We're hoping that will be in product this year. But right now, there is a beta program, and it is possible to go and start using that to experiment how consuming that value online works for you as customers. Okay, so that's it for me. I don't know if there are any questions on the chat. Yeah.
Doesn't look like
Hi,
it, Mark.
Mark. I see no questions at this time.
Okay, well, I shall hand on to Joseph.
Can everybody hear me okay?
We can now. Thank you, Joe.
Okay, super. Hi, I'm Joe Krozak, Vice President of Krozak Information Technologies. We are a longtime I2 partner operating headquartered in the United States. I wanted to talk a little bit this morning about I2 deployments that we've done over a number of different implementations, different customers, spanning the government and also commercial environments, and some of the key considerations that we think are important when considering the cloud deployment. First, talk a little bit about ourselves. So we're what we like to call a boutique consultancy, operating and developing solutions around advanced software and management services and systems to the government, as well as Fortune 500 and mid-market customers. What that means in terms of boutique is we tend to find ourselves in atypical environments. So we're very close to the core data of our customers, their core logic, and typically the kinds of solutions that we're developing really have life and limb implications. They are supporting critical missions, sometimes around the globe. So the kinds of considerations that we end up being involved in are anything but trivial. They start from the very beginnings of conceptualization of what the solution will be, all the way through the design and the architecture implementation, all the way to deploying. And so for us, a victory is the production deployment of a solution that's going to help our customers complete their missions. So that's a key focus for us. We've been founded in 1998. We're based in the states of Virginia and Maryland, so this is around the Washington metro area. A lot of the other things that you see here really kind of underlie the fact that we do tend to have a bit of a specialization in the federal space, particularly with classified projects. So, pretty much the bulk of us are cleared at the highest level and find ourselves implementing technologies, particularly I2 solutions in those environments. We are a Schedule 70 contract holder, which means we can prime work for the United States government. We're ISO 9001, 20001, and 27001 certified. So part of our commitment to leveraging our own internal processes for ensuring quality and full accountability from an information technology perspective, and we're pursuing CMMI Level 3 Dev and Services certification. I think the key point on this slide, though, is our I2 partnership, right? So we've been working with I2 and I2 technologies, particularly within the ecosphere of I2, since 2009. So in that particular instance, some technologies such as the recommendation engine that's often packaged in I2 solutions, we were enabled back then and have done numerous deployments really around the globe. I want to talk a little bit about our deployments, really from number one, kind of an overall perspective, typically what these deployments look like, and then some key considerations that we've collected over the years. So this might be a little bit of an eye chart, but we'll kind of go through it. It's actually not as complicated as it might seem. So Mark did a great job of explaining and comparing and contrasting virtual machines with container-based platforms, and that's also relevant here as well, right? I think he talked about the relative lightweight and efficiencies of operating in a container environment. And it's really exciting that the I2 product set is moving in that direction. To date, the kinds of deployments that we've seen have been decidedly more on the virtual machine side, but deployed within a cloud environment. So kind of looking at this picture, you'll see the big gray box in the background with VPC, or virtual private cloud. A lot of the elements on this slide happen to be from an Amazon Web Services perspective, but you're going to find analogous definitions in all of the other cloud technologies, whether it's IBM Cloud or Microsoft Azure or what have you. They're all similar kinds of concepts. The names are somewhat different, but that virtual private cloud you can think of as a virtual network. So those are all the virtual IP addresses and how they're arranged, organized, and along with all the necessary infrastructure that comprises your solution in the cloud. So in a typical cloud deployment blueprint for I2, you've got some kind of a virtual private cloud environment, or VPC, and then you'll see along the right-hand side these large rectangles, ACLs, access control lists. You'll see a public tier and an application tier that's private, and a data or core services tier that's private. And so that's typically how we see these solutions deployed, and a lot of times it's kind of mandated by the customer environment. What this really means is you try to limit the surface attack from a public perspective. So rather than having key assets like databases and application servers sitting in an environment where they can be seen from a public perspective, you typically narrow that field of vision down to one access point that you can control. And so that's why you see that lone box up in the top tier, because you typically have some kind of a reverse proxy, well guarded, with a couple of pinholes to get into it over certain ports to allow very controlled protocols and operations to that resource. And then in turn, that resource goes and federates its calls across a number of services that are deeper in the architecture and more private. So that's what you'll see, all those boxes that are in the next two rows underneath it are in access control lists that are private, right? Private to the institution. Along the left-hand side, there'll usually be yet another kind of small portal into the environment to allow developers and integrators to be able to have access to this back end. So that's what you see with the Bastion server there. A number of the components, and so each one of these boxes is an effect a virtual machine. In AWS parlance, it's an EC2 or Elastic Compute Cloud technology, but it's analogous to a virtual machine. And like I said, you'll see these same kinds of concepts regardless of what cloud environment that you're in. What you see going along the middle bar really are typical items that we'll see in a deployment. You don't necessarily have to have all of these things, and some of the names might change depending on the environment, but you'll typically, coming from the left-hand side, particularly with EIA, there's an information store, which is a shared repository of entity and link information that you typically want customers to be able to leverage from Analyst Notebook, whether it's the web-based version or the full deployment. So a key aspect of that is getting data into the system. So we know that there are a couple of main ways of doing that for I2, both push and pull kinds of approaches. Either you're connecting to an external database and bringing information in on sort of an on-demand basis, which would be a connector, or sort of a push-driven, where you've got one or more systems, maybe within the organization, or can even be deployed on the internet, that you're pulling information from and putting into that information store. So that first box there, data stage, that's an example of an extract, transform, load piece of technology that would be responsible for a push-driven acquisition of data from one or more systems, external systems, into that information store. So you'll typically have some piece like this that's part of the solution. The next two are EIA related, and they don't have to be two separate boxes, but often for a large deployment for scalability, you'll separate the maintenance of the indexes that support the query aspects of EIA into its own box or its own server, if you will, with its own resources. And that might be separate from the rest of the EIA solution, housing control and data aspects. So those are those next two ones to the right-hand side. The next thing that we typically see is, and we'll get into this a little bit later as well, the solutions that we employ typically involve not only EIA, but also some form of analytics. So we know that, for instance, the EIA suites is pretty much unparalleled when you're talking about looking at important items within the information entities and how they're interconnected over links. But often customers want to also see their data summarized and aggregated differently. So pie charts, bar charts, in an interactive manner where you can slice and dice data. So it's maybe similar data, but a different visualization, if you will, from something you'd see in Analyst Notebook. So there'll be some kind of an analytics platform. You'll see here it says Cognos from IBM, but we've seen Tableau, Power BI. So there are a wide range of technologies that can fill this, but there's typically some interest in that kind of capability. The last two boxes in that middle row are about the recommendation engine. This particular component is from IBM. There are some other competitors as well, like Sensing G2. And really what this is an engine that is able to assist in the discovery of non-obvious relationships, right, in your data. So you might be interested in the relationships between an individual and maybe somebody on a watch list, but that may not be an obvious relationship. It might happen through, 2, 3, or 4 degrees of separation or more. So this is an engine that we've found can work in conjunction with EIA to be able to paint the full picture to analysts. Not only the relationships that we know about in the data, but the ones that aren't obvious. So all of this, including the databases at the bottom and so forth, that really make up this sort of standard blueprint that we see. All of this you'll see within that dashed line. And so, that's all sitting out in the cloud off premise, and typically that's stitched back to an on-premise environment. So that's what you see at the bottom, connections to analysts, to Active Directory. So typically these environments want you to be able to use some kind of certificate-based authentication, like a CAC card or something like that, to get into the environment. So that's going to go against credentials that are stored back in the enterprise, back on-premise within Active Directory or some kind of an LDAP repository. And then you see on the right-hand side, well, how's that done? A lot of times that's a VPN, a site-to-site VPN connection. You might get some kind of a direct connection as well to help with latency. But this is really kind of the blueprint, a hybrid cloud deployment, if you will. So what are some of the things that we've seen that are of interest, things to consider in these kinds of deployments? Now, some of these things are not exclusive to cloud environments, but what we've seen is that they've become more prominent in cloud environments than they were even in their on-premise equivalents before the cloud was really a prominent offering. So we've got 10 of them. The first one, you may be familiar with the ubiquitous Log4j logging framework. It's baked into COTS products as well as custom products. It's been around at this point for decades. It's sort of the logging framework of choice for developers. We certainly use it as well. And it's been the source of several vulnerabilities over the last few years, in particularly government customers across the US, but we've seen it in Canada, and I'm sure it's prevalent and relevant in other countries as well, have put a lot of focus into vulnerabilities that have become exposed or at least unearthed within that product. And it's kind of a slow drip of vulnerabilities. It seems like every few weeks or so there's a new one that comes up. And there are parts of the government that really focus on exposing these and basically requiring that those be mitigated. And that's a key consideration, particularly in a cloud environments that we've seen, is that there is increased focus on security. And mitigating these issues is extremely important. And it's the kind of thing that, if not done in a timely manner, can actually threaten your authority to operate. That ATO is often a key consideration for any solution that you're developing to actually be able to operate against production data. So that's very important. And often obtaining ATO and retaining ATO are huge deals. Right? So this is something to definitely be aware of. I2 is vigilant in not only getting ahead of and knowing right away when these vulnerabilities have been detected, but mitigating them. So I2, I know for us, they've been just absolutely vital to our ability to be able to maintain ATOs for our customers. We'll typically go ahead, pass the word that the customer has noticed that there's a new vulnerability that's come up on the scans, and within a day or so, we've got a mitigation that we can put in place. So this is the kind of thing we're very familiar with. The second item is something that can be a little bit maybe not an obvious thing up front. We talked about virtual machines. I mentioned EC2 for AWS. In fact, that they're basically virtual machines in the cloud. And so they have components that are virtualized as well. They have virtual disks on them that operate like the disks on a computer. And what we found is that there are different types of disks that can be associated with these instances, and they can have dramatically different performance characteristics. And so those characteristics can potentially bottleneck the ETL process that I talked about before. If you've got a really big solution, that might take days or weeks, even months, to load all of that data, just depending on how much you're talking about. And selecting the proper disk types with the proper performance characteristics, usually based on solid state drives, and the ability to basically dial the input-output operations per second that those disks can support is critical to having a solution that can meet your time characteristics. Some of our environments that we have done with EIA have more than 600 million entities and links in them, so getting that all loaded takes a long time if you don't have the right disk types as part of the picture. The next point that is somewhat related to item 1, but goes further, are your ATO security requirements. So this is something that we, again, have seen more prominently in the cloud environments where the operators of those cloud environments have a series of specific security requirements. They'll often call them STIGs, but they're known by a number of different names. And those are the kinds of requirements. There might be hundreds, might be thousands, depending on the environment you're in, but they're key to obtaining your authority to operate. Basically, they're looking at how security conscious your solution is, and does it have vulnerabilities in the underlying software that comprises it, and how are those mitigated? How is control kept across all the different parts of your solution? And so it's very important to have a handle on these, to have a good relationship with the information assurance personnel who might be operating on behalf of your customers, so that this is the kind of thing you want to get your hands around very early. We have a lot of experience with this. We've done multiple implementations across federal government space, where each one has its own set of security requirements. And so we already know how to answer a lot of those questions, pretty much all those questions, particularly from an I2 perspective, and can provide a lot of guidance to accelerate this process. The fourth item down there is somewhat related as well, and that is, if you remember in that picture that I showed, I said that the typical environment is a hybrid one. So you've got the bulk of the solution operating in the cloud, but there's paths back to on-premise for critical resources like the user repository for Active Directory, but other things. We've been in environments where actually the ability of that software out in the cloud to talk to the internet means that it goes back to on-premise and across on-premise resources. But what that means is that path is very important, between off and on-premise, and not only is the performance of that path important, but the stability is important. It really could be the key to your solution. And what we've found is, depending on the environment you're in, that path might be owned by multiple agencies. May not be something that's even in your direct customer's control. We have an example of that now with one of our customers, where that path is actually owned by 5 different agencies and 5 different sets of resources managing that. So it's key to understand that. If you've got any issues with performance or stability, you want to make sure that you leverage your relationships so that you can marshal the right resources, which might be across different organizations, to be able to troubleshoot and resolve in a timely manner. Going on to number 5, this is just an item of interest. Some of these environments, depending on where you might be, don't allow direct cloud console access. So you'll be working with potentially other members, perhaps of the administrators of that cloud, to help provision some key resources like those virtual machines I talked about. So you just want to plan accordingly for that. That might take a little bit more time to go ahead and get those things provisioned. So those relationships are key. Number 6, some of those environments may also mandate certain kinds of frameworks be used in solutions that get deployed in those environments. A key one here is AAA, or Authentication, Authorization, and Accounting. So a lot of times, and we've run into this in several of our deployments, where they'll have some big piece of infrastructure that they've stood up to handle user authentication, and they want to be able to control password timeouts, certificate timeouts, and things like that in a way that's specific to that agency. And so that'll require some additional development and integration of the components that make up the EIA solution to use those environments. Sometimes you can get a waiver, so certainly try to seek that if it's the kind of thing where you can't absorb the schedule or the technical time or effort to do those integrations. But it's definitely something you want to know about upfront, depending on the environment you're going into, and be able to plan accordingly. Number 7, there's infrastructure within that virtual network environment that may be owned and administered by other groups, so load balancers and firewalls. So those are things that in that picture that I showed you, they were kind of invisible, but you could almost think of them as filling up that box in different pieces and parts, depending on the environment that you're in. And so if you've got an issue, perhaps with performance, getting maybe balancing load across EIA or some other components of the solution, you might be working with other people outside of your team to be able to troubleshoot and resolve those issues. So as with some of the other items that I mentioned above, relationships are key to being able to collaborate, troubleshoot, and resolve issues. And again, not necessarily something exclusive to clouds, but definitely we've seen that it's a more prominent consideration to take into account. Rounding out our final 3 here, item 8 is something that also we have seen more prominent in the cloud environment, which is a lot of those environments have sub-environments. So they will not just allow you to put something directly in production, but they'll have several sub-environments that have different requirements to them and have different entry and exit criteria associated with them. So here's an example. It's definitely one from one of the major agencies in the US, but probably analogous in other countries as well. They'll have a development or an agile environment. That you've got to meet the entry and exit criteria to get into that. A lot of times that's involving security, vulnerability scans and mitigations, submission of architecture information up front to be reviewed by personnel before you can progress to the next environment, which is test, and then the next stage in prod. So I think the thing to be aware of there is just, again, understand what the process is, what these environments are, who the stakeholders are, and just plan accordingly. All of these points, including this one, we have a lot of experience in, including developing project plans that take all of these into account. We've been in enough environments that we actually know have a blueprint for project plans and what the kinds of gates going in and out are. So it's definitely something that we can help with, but certainly something that you just want to keep in mind. Number 9, leveraging automated cloud mechanisms. This is another thing that's very important. One is cost, right? So when you're operating in the cloud, there are so many benefits to that, but you do want to get a handle on costs. Some of these components charge continuously, as long as you've got software operating, you're getting sort of charged by the minute, or even more granular than that. So if you're in an environment like a dev or a test or stage environment that doesn't have to be 24-hour operation, you want to leverage some of the cloud mechanisms. For instance, for AWS, there's an instance scheduler that can spin down resources that aren't needed, let's say in the evenings, and then spin them back up again the next day. So that's a key to controlling your costs and making sure that that doesn't run out of the range of your budgets. And then the other thing are things like Systems Manager and CloudWatch, particularly for AWS, but they're again comparable pieces in other cloud infrastructures to help manage the logs that are part of all the different components in your environment. So EIA and recommendation engine, all of these pieces and parts have logs that describe what's going on with them. And so to help with maintaining all of that and having a single pane of glass to look at, you can leverage solutions like Systems Manager to scrape those logs and ship them to a central place, for instance, like CloudWatch, where you can view all the activities and also set triggers if there's any issues to notify people. So that's a key way to help manage your infrastructure. And then finally, what we found is that real solutions involve not only I2, but also a combination of different components. You might be integrating with another system that they already have in place, and they want to have the two work together. And then there are also a number of custom components, depending on the kind of environment that you're in, that you may be developing in conjunction with I2. So there are some mechanisms that we found very helpful in automating the development and deployment of custom components in conjunction with I2 so that you're maintaining security and operating very efficiently. We'll give you an example of one environment here, sort of similar to the diagrams that Mark showed in his. This is typical AWS architecture or cloud environment diagram. And this is an example of the kind of blueprint for DevSecOps that we're now beginning to deploy in our customer engagements. So you'll see there in the middle, the user there is basically a developer. So the idea is that if you've got custom software, that's part of the solution. They might be checking in that software to the right. You see those blue boxes is basically some automated process of a code pipeline. So whether that code is being committed to a repository and then being built and assembled into deployment modules and deployed is really what's going on there. You'll see to the right that Elastic Beanstalk. That's really just an example of it might be a web application or it might be a set of web services that you're trying to test. And so there's an automated deployment to that environment to be able to facilitate that testing. All along the top really is just an accounting of different activities that are happening along that build. And so those are captured typically in logs for AWS. That's all within the CloudWatch realm. And then those events, log entries turn into events, and those can drive notifications. That's that SNS in the upper left-hand corner. And so that might be a series of emails to stakeholders, right? So it might be members of the customer set who are interested in seeing the status of the builds or seeing the status of security scans that are happening along the bottom of that diagram and having that delivered as email notifications. So this is just an example. This is certainly nothing required for I2, but what we found is that you typically want to have some kind of an automated environment if you're spinning up custom products or integrating custom products with I2. And again, this is an area we have a lot of expertise and are doing more and more of this across our customer set. So that's pretty much everything that that I had to talk about. Are there any questions on any of this?
If you guys have any questions, feel free to put them in the chat box. I know you don't really have the ability to speak, but we can answer any questions you may have. And then again, we can send out questions or answers to any questions. If you have something after the fact, we will be emailing out a recording. Oh, there is one. Okay. Great.
Yeah, I see that question from Mr. Woodring. And I think, yeah, so the questioner, Mr. Todd, seemed to advocate for the container deployment, whereas Mr. Krozak seemed to describe a more traditional deployment method in virtual machines. Was that done for scalability and security? And I really think the answer is that the movement toward containers, and particularly with what's going on with I2, and Mark can get into more specifics is exciting, and it's something that I think is definitely a key part of the future of I2. What we've been doing are implementations over several years, and so in those environments, the typically those have been virtual machines, but going forward, we definitely see a migration from that kind of traditional kind of an architecture to leveraging the container-based ones and the serverless offerings that are in the cloud. So really, that's the future, if you will. We're excited about that. Did that answer the question? Yep, I see. Thank you. All right, super. Any other questions?
Thanks, Joe. It seems like we may have answered all the questions that are available, and I think at this point we can go ahead and wrap up the webinar. And thanks again to Mark Todd, our Chief Architect, and Joe Krozak, owner of Krozak Information Systems. And everybody, thanks for joining and have a great day.